This time, Kirchhoff's laws, and at level 1 it should be fairly straightforward. Let's have a look. First one is an application of Kirchhoff's voltage law. And Kirchhoff's voltage law, you may remember, says that the total potential differences across every component round a closed loop in a circuit is 0. In other words, the total change in potential between one point in the circuit and another point in the circuit is constant. It doesn't matter which way you go to get there. Now, let's have a look in going from the bottom to the top. From the bottom to the top is the potential difference that this voltmeter is measuring. The potential at this point here minus the potential at that point there. And going from the bottom to the top goes, well, through this 13 volt source the wrong way, from the positive to the negative. So this point here is going to be 13 volts below this point here. That's what this is telling us. This is the positive end, this is the negative end. The positive end is 13 volts above the negative end. If we start here, we must have gone down by 13 volts to get there. Similar here. To get from here to here, we've gone down by 14 volts. So in total, to go from here to here, through these two voltage sources, we've gone down by 13 plus 14, or 27 volts. So the voltmeter will be measuring minus 27, because it's measuring the voltage there minus the voltage here, and the voltage here is 27 volts below the voltage there. So, minus 27. Great. Next one. A current one. Okay, this is Kirchhoff's current law. And Kirchhoff's current law says that the total net flow of currents into a node is 0. In other words, all the currents flowing into the node must equal all of the currents flowing out of the node. Here we have a current flowing into the node is going through this ammeter. It's being measured through this ammeter from the red terminal to the black terminal. That's fine. The total current flowing out of this node, where there's 10 milliamps flowing this way and there's 12 milliamps flowing down there, so the total current flowing out of that node is 22 milliamps. That must be equal to the current flowing into the node, therefore there must be 22 milliamps flowing in this direction through this ammeter. Ammeters measure the current from the red to the black, so it will be measuring 22 milliamps. That's about all there is to level 1. They're all either voltage law questions or current law questions, and they're all almost as easy as that. This is a slight variation only. Again, if we look at the circuit and we say, how do you get from the black to the red terminal of the voltmeter? Because that will give us what the voltmeter is measuring. And the answer is, we go up here, we find a 5 volt voltage source, but we're going from the positive to the negative end of the voltage source, so we're dropping minus 5 volts. We are now 5 volts below where we started down here. Keep on going round, and now we've hit a 10 volt voltage source. But again, we hit the positive side of it, and the negative side of it is where we're going, so we're going to go down by 10 volts. This point here is 10 volts above this point here, so we're going down by another 10 volts. We've gone in total down by 15 volts to get from here to here. If we called this ground, we'd be at 0, 0, 0, 0, 0, 0, 0, 0, minus 5. Minus 5, minus 5, minus 5, minus 5, minus 5, minus 5, minus 15, minus 15. That point must be minus 15 volts with respect to that point there. So the voltmeter would measure minus 15. Fine. Another current one, which you might have to think slightly harder about, but not that much. Let's consider this node in the circuit here. This node, well, we have a current flowing in this direction 10 milliamps. There's a current flowing in this direction 14 milliamps. The only place that can come from is along this wire and through this resistor. So there must be 14 milliamps going in this direction here as well. So looking at that node here, we've got 10 milliamps going that way and 14 milliamps coming this way. Apply Kirchhoff's current law to that point in the circuit there, and we've got a total of 10 milliamps plus 14 milliamps of 24 milliamps that must be going up through the ammeter there. So we've got 24 milliamps flowing up from the black to the red terminal of the ammeter. But ammeters measure current from the red to the black. And this one has got 24 milliamps going from the black to the red, which is the other direction, so it would actually read minus 24 milliamps. And so on. Right, over to you.